Our new unit is on real numbers and the Pythagorean theorem. The first thing we're going to talk about when we talk about numbers is square roots, which is a specific type of number. A square root of a number is a number that, when multiplied by itself, equals the given number. It's a bit of a wordy definition, so let me show you what that really means using numbers. 2 squared, which is 2 times 2, equals 4. That means that the square root of 4 is 2, because 2 times 2 is 4, okay? Or 2 squared. So you notice that when you square something and you take the square root of something, those are opposites. Okay, so the square root of 4 is 2, because 2 times 2 gives you 4. So when you're asked to find the square root of something, what they're asking is what number of times itself gives you what you're looking for. A perfect square is a number with an integer as its square root. Okay? Example of a perfect square would be 1. So 1 squared, which is 1 times 1, is 1. That means that the square root of 1 is 1. We're going to make a whole list of all the perfect squares. Let's move on to 2. 2 squared, which is 2 times 2, is 4. We already did this one. That means the square root of 4 is 2. Let's keep going. 3 squared, which is 3 times 3, is 9. That means that the square root of 9 is 3. So these are going to be perfect squares right here. These are perfect squares. These are their square roots. Okay, I want you to make a list going from 1 through 10 and then 11 through 20. And when you've finished your list of perfect squares, it should look like this. So the square root of, say, 49 is 7, because 7 times 7 is 49. And now you have a list of 1 through 20. So if you want to find the square root of 169, you look for it in the list. Square root of 169 is 13. Eventually, throughout your math career, you'll start to memorize perfect squares because they come up quite often. And they're really useful if we can memorize the answer and we don't need a calculator. In addition to having these perfect squares here, we can also have a square root of a fraction. Let's take a look at what that looks like. Let's say we have the square root of 25 over 144. So you're taking the square root of 25 over 144. Now, it might be hard to think of a fraction that multiplied by itself gives you 25 144ths. But there's an easy way to think of this. We simply take the square root of the numerator, so the square root of 25, and then separately the square root of the denominator, which is 144. And the square root of 25 is 5. The square root of 144 is 12. So if you're trying to find the square root of a fraction, you break it up into 2 smaller square root symbols, and you find the square root of both. So that would give me 5/12. Then you're going to move on to the next page, and there'll be some practice with order of operations and different types of square roots. So turning the page over, let's do this example. I'm asked to find the 2 square roots. So you might be thinking to yourself, well, what do you mean there are 2? If you think about the square root of 81, well, 9 times 9 is 81. So the square root of 81 does equal 9. Also, negative 9 times negative 9 equals 81. So the square root of 81 is also equal to negative 9. So if you're asked to find the square root of 81, your answer is going to be both a positive and a negative 9. Because both positive and negative 9 would give you 81. So for example 2, let's say you're asked, what is the square root of negative 16? So what number multiplied by itself can give you negative 16? Let's think about it. So 4 times 4 gives you positive 16. Negative 4 times negative 4 gives you positive 16. So there is no square root of negative 16, so it does not exist. Okay. However, the negative square root of 16 is negative 4. So if the negative is on the outside, it's okay. If it's on the inside, it's not okay. Okay, so the negative can't be on the inside. So we have 2 more examples to do. Example 3, let's say you're asked to evaluate 5 square root 36 plus the square root of 9 squared minus 5. Well, we're going to use order of operations on this one. So order of operations is PEMDAS, if you remember correctly. So parentheses, exponents, multiplication, division, addition, and subtraction. Now notice there is no S that stands for square roots. Right? Square root is actually a type of exponent. So it's included in the exponent step. The square root is when an exponent is 1/2. So when you have square roots and eventually cube roots and fourth roots and fifth roots, that's when you have exponents that are fractions. So we consider it part of the exponents group when we start doing our order of operations. And we just take this one line at a time. So first we're going to do parentheses. So inside of our parentheses we have the square root of 9. The square root of 9 is 3. So I change that and I move one line down. Okay. No more parentheses left. So next step is the exponents. So 3 squared is 9. Now notice this right here. The square root of 9 and then squared, these actually cancel each other out. And that's how you're left with 9. So you can kind of skip this step if you want. Okay. But then we keep moving along. So I still have no more exponents, but I have a square root symbol, so square root of 36 is 6. Now because the 5 is next to it, that means multiplication. So I'm doing 5 times 6 plus 9 minus 5. And I keep going through the process. 5 times 6 is 30. I add left to right. 39 minus 5, eventually 34. So 34 is my answer. So that's how you do order of operations using square roots. In example 4, I'm asked to solve for x. And I'm given the equation x squared plus 4 equals 20. My first step when solving for x is to get the x by itself. My first step in solving for x is to get the x by itself. So right now we're adding 4 to it. I need to do the opposite of adding 4, which would be subtracting 4. So I'm going to subtract 4 from both sides. Subtract 4 on the left, subtract 4 on the right. And I'm left with x squared equals 16. Now, I still need to solve for x. I need to get x by itself. Right now it's being squared. So what is the opposite of squaring something? It's taking the square root. So this is saying some number times itself is 16. Well, the definition of finding a number that times itself is the square root. So we're going to take the square root of both sides. So the square root here and the square root here. The square root of x squared is simply x. Remember how those cancel each other out? The square root of 16 is both positive and negative 4. Okay? Don't forget about the positive and negative. And we just call that a plus minus symbol. And that's it for square roots. The next step is going to be practice from the textbook. Then after that, you'll move on to cube roots. It's a different type of root.